Hello aspirants. So this is the problem which got touched today in the class, and as you can see this is a problem on constrained motion, and it's a very pretty simple question, but many times you'll find that students kind of get stuck while handling this kind of constrained motion situation. So I would like to demystify it, and let's see how well we can cook up our show. So the problem is on constrained motion. Let's read the question first and try to do some sketch work so that our mind gets enough fuel to start functioning. Okay. चलिए, two blocks of identical mass lie stationary on a horizontal table of length 1 meter. तो length आपको कितना दिया हुआ है? 100 सेंटीमीटर. Correct? Okay. there are two blocks identical mass है. इसका mass भी m है, तो इसका mass भी आपका m ही है. To what distance x from point A should its free end be moved so that blocks collide with each other? Neglect friction. Okay, so this is very crucial. You don't have to deal with friction over here. And this is the free end of the string, which is connecting both the masses through this two pulley system. It's a two block system, and two pulleys are utilized in connection, this particular connection. So the question is asking you to find out how much this free endpoint A you are supposed to move. Now when I talk about moving, you're not jerking it, you're not causing any kind of acceleration to the masses, gentle moving. Okay, that's how the question is stated, and the choice of words tell you यहाँ कोई ऐसा heavy tension नहीं generate किया जा रहा है string में, which is kind of causing a sort of acceleration to the masses. Gently move किया, slowly, and then both the masses collide with each other. So the question is, suppose करो point A से आपने इसको move किया point B तक, तो the question is simply asking you कितना आपका movement हुआ. X is how many centimeters. Okay. That is, the free end has moved from point A to point B. We have been simply asked to find x. Let's see how to crack this kind of questions. Simple free body diagram बना देते हैं for our mind to start functioning. बाकी तो free body diagram में we can always show mg over here. We can show a sort of normal reaction force over here like this. But the question is about the kind of tension which is existing in the string, which is trying to pull this m towards m will move right, whereas this m will move left, right, and eventually both of them will gently move towards each other and collide. That means the total distance covered by them during their motion before they started actually exhibiting motion and to the point where they collided, the total distance together they cover a distance of 100 centimeters. That is L, which has been provided in the question. Okay, so that I'm just drawing a simple free body diagram. Can you tell me how many tensions are actually trying to pull this M towards the positive x direction? I would say 3T. Just see, there are three tensions, one over here, one over here, one over here for this mass M, right? So इसमें 3T लग रहा है. Likewise, if I draw the free body diagram of the mass which is on the right side, again I can see this is mg. Since friction is not present, I'm less concerned about mg, and then over here I will be more concerned towards the kind of tension and the movement they are exhibiting in the x-axis, that is towards the positive x direction and towards the negative x direction. So for this mass, definitely there are two strings which are generating the pull towards the negative x direction, and they will club together to generate a total force of 2T. Okay, over here 3T. So you can say that, okay, now you can say few things over here. Okay, let's say the prior collision की just पहले और just collide करने के बाद ये वाला मास का मूवमेंट इधर कितना हुआ है, हम मान लेते हैं k हुआ है, k सेंटीमीटर्स, ओके। और ये वाले मास का मूवमेंट इधर कितना हुआ है, हम मान लेते हैं k डैश सेंटीमीटर। एक चीज तो हमें पता है यहाँ से कि k प्लस k डैश टोटल कितना हो जाएगा मेरा 100 सेंटीमीटर्स, नो डाउट्स। अब हम आगे बढ़ते हैं। अगर ये वाला मास m सपोज करो k meters towards the k centimeters towards the right move करता है towards the positive x direction, can you tell me how much the string is gonna get slackened by how many centimeters? 3k 3k times string का slackening होगा, right? अगर जब ये वाला मास आपका किधर मूव करता है, राइट साइड में। लाइकवाइज ये वाला मास जब आपका मूव करेगा नेगेटिव एक्स डायरेक्शन या लेफ्ट साइड में, तो स्ट्रिंग का टोटल स्लैकनिंग कितना होगा 2k डैश। देख लीजिए आप, ये अगर k मीटर इधर जाता है, k डैश सेंटीमीटर इधर जाता है, तो ऊपर वाली रस्सी और नीचे वाली रस्सी along the two ends of the pulley will club together and generate a total 2k dash centimeter slackness in the string. Likewise for this mass, if you focus, you will find that if it exhibits a motion of k centimeters in the positive x direction, the total length of the string which will get slackened off will be k dash plus k dash plus k dash. That will k plus k plus k, that will fetch you a value of 3k centimeters. Now if I add these two, don't you think this is what we have been asked to determine? Because this is the total slackness of the string which got generated because of the movement of masses, because of the force you applied at the free end at point A, and this total slackness of the string has to be compensated by the pull at the free end. So definitely your x has to be 3k plus 2k dash for the string to remain tight, right? Okay, so now we got some beautiful expressions over here. One is this one is this one. How about the, what can you say about when you focus on this tension expression for both the masses? Can you deduce something else? Don't you think this gives you another beautiful expression or connection or relation between k and k dash? This is 3D and this one is 2D, so definitely your k over k dash should be equal to 3 over 2. Just have a look, the ratio should be equal to 3 over 2. Because on the left side block, the tension which is prominent and causing an exhibition of motion along the positive x-axis is of magnitude 3t, and at the same time for the block on the right hand side is getting pulled towards the negative x direction by a tension of 2t. So if we try to find the ratio of the distances moved by these two blocks, definitely there will be the ratio of the tensions, right? Because there is no such prominent acceleration as such. The blocks are gently moving towards each other. So this is the relationship which we can develop over here. Now we can use this to fund this equation. Let's fund it. Just try to plug in the value of k over here. You'll be getting 3 k dash over 2 plus k dash is 100 centimeters, right? So this gives you the value of k dash as 40 centimeters, and again the value of k can easily be calculated using this 60 centimeters. See, the block which was initially on the left hand side has moved a total distance of 60 centimeters under the influence of 3D tension, whereas the block which is on the right hand side has exhibited a motion, a total displacement of 40 centimeters under the influence of 2D tension, and both of them have glided, covered a total distance of 100 centimeters. Now the question is, how much is our x, that is how much this string got slackened by, which got compensated by pulling the free end A. So x will turn out to be, just plug in the values of k dash and k in this equation and you'll get x is equal to 180 plus 80. That is 260 centimeters, right? Or more precisely, you can just say 2.6 meters. I hope this approach is pretty much clear to all of you, and in case you are having any more queries or doubts, feel free to use the comment section, and I'll be most chuffed, most delighted to sort out your queries. But this is a simple approach, and this is a question on constrained motion. This is how you try to frame equations and then establish a relationship between the various equations which you have framed, and you can easily crack this kind of question. So the value of x, that is the extension at the free end, that is the pull at the free end, should be equal to 2.6 meters. Thank you for watching this video. Please press the bell icon and like and subscribe button. Thank you. Have a great day ahead.